after kids really work on composing and decomposing numbers and understanding, how to basically add or subtract them, we also want to talk about place value. And so that just means having ones, like, 0 through 9, get changed into tens because of how much is in a bundle. And then from tens, going all the way up to getting to hundreds. So what I want to show you is kind of how we represent them in class, what kids do to learn them, and then how we use that for like addition and subtraction. So first I kind of want to show you some of the objects we use. So I have these little cubes. They're kind of hard to see, but they're little cubes. There's about 10 of them, and these would represent our ones. So if we're counting out, they can easily pull one at a time. They see them in a group. If they see a group of 4, they know it's 4 ones, and that's great. What you can do is you can stack these cubes in order to get a stick or a bar, and this is a group of 10, and the kids know when they see the stack like this that this should be a group of 10. Some of them will still count it out, but this represents that group of 10. When you have 10 of these stuck together, then you get a group of 100s. And so that's, 10 by 10, and that gets you that cube or that square of 100. So the kids know when they see a square that it usually represents 100. Some of them still check to make sure there's 10 sections, but that makes the 100. So it's kind of nice when you're teaching the kids, for adding up different stuff, we can look at it that way. We know that, different lines together will make something new. So if we have 10 individual pieces, if you put them together, it equals 110. So that's where you get the 10 from. You put the 1 in the tens place. And then if you have 10 bundles of these, that's where you put that 1 in the hundreds place, and then you're left with the zeros to make that 100. So we use sticks, we use those cubes. What's kind of nice is you can see what you've got. So if you have 100 and 110, you're at 110, and then you have 1, 2, 3, 4, 5, 6, 7 ones, then you are at 110, or 100, 110, and 7 ones. You can kind of see where there's the hundreds place, the tens place, and the ones place. You can kind of see how numbers are formed. You can kind of We use those ways to show the hundreds, tens, and ones because we want kids to understand that as you make a bigger number, you're still using what you've learned. You're just adding to it. So like you have your ones, but the ones can't always just stay in the ones place. They have to go to the tens place once you get that group of 10. And then depending on how many tens you have, then that makes a bigger number. And then once you get a certain amount of tens, if you get 10 tens, it goes to hundreds, and then you have a certain amount of hundreds. And some kids are counting up to 1,000 and past 1,000 now. So it's very, very good to make sure that they keep using the cubes, keep using the actual sticks, because you want them to be able to move stuff around, get that concrete stuff, but then you're teaching them too how to do it pictorially and abstract thinking. So we're going to show you now how to do it with pictures and how the kids would do it on an assignment that they would have in class. So, for example, if I wanted to see what, this would mean for a number. I have 100, I have 2 tens, or 20, because kids know that the amount of tens you have makes the next number. So this would be 20 because it's the 2 tens. And then I have 3 ones. This is called expanded form, but again, it's just another way to show their thinking. It's a way to show that they know that's a group of 100, that they know that the 2 tens together make 20, that they know that there's 3 ones. And so then I'm able to easily see like 100, okay, I know that the 2 goes into that place. I know that the 3 goes into the ones place, and then you bring it down, you get 123. Another way that we can kind of stack it to make sure that it makes a little bit more sense is we can do our little T-chart, hundreds, tens, and ones, and we can stack it to see what we get. We have 100, we don't have anything in the tens place or anything in the ones place. We have 20, we don't have anything in the hundreds place, we don't have anything in the ones place, we got that 2 in the tens place, and we've got 3, which is only in the ones place. And if you go down our line, you get 0 plus 0 is 0, plus 3 is 3, you get 0 in the tens, but then 2 more in the tens, so then that would be 2. You get 1 in the hundreds and nothing anywhere else, so you bring that down and you get 100. So that's kind of how we use our place value in order to show and represent numbers when we're just pulling out a number. For addition and subtraction, it's a little bit different. When we're adding our numbers, we cannot use our standard algorithm where we put it in the row and we add down, because we want to make sure that they understand what they're actually doing when they have those bigger numbers. For example, if I want to do 23 plus 45. For us, it's super easy. We're like, oh, 8, there we go. Oh, this is 6, done. That's it. And it is really nice. But I can tell you, when I first started teaching math for younger kids, I didn't know how to explain what I did. I said, I just added them. That's it. It went down the line. It's fine. And I can tell you, my kids stood there and were like, what are you talking about? So this is great. And you can use it as a check, because it might help them to see, oh, I wasn't getting the right answer. I need to change something. But what we want to do is we want to teach them how to think, how to process it. And then they need to be able to show us that, because we want to make sure they understand what they're doing. So the kids will look at this and say, okay, I've got 2 10s, I've got 3 1s, and I'm adding. So I'm going to draw more, which is part of the math vocabulary they're learning. So they have 4 10s and 5 1s. And then what they do is you have to look at the ones place first. And you see you have 5 plus 3 1s, and that's 8 1s. And then you have 4 plus 2 10s, and that is 6 10s. Now, did they get the same answer as us? Yes. But I'm able to see their thinking. I'm able to see that they put the 10s there. I'm able to see that they put the 1s there. What's nice about this is if they're looking at their work or they're checking their work and maybe they forgot to draw a 1 and they get the wrong answer, they get a 67. They're able to go back and say, what did I do wrong? And I'm able to help them be like, well, you did the right 10s, but how many 1s are you supposed to have? You're not supposed to have 4 1s, you're supposed to have 5 1s. And the kids are able to then correct themselves, or I can help correct them, or they can help correct each other, which is nice when they're working in math groups. When you're doing subtraction, it's a little different because you're taking away those numbers. So if we have 40, we use the same numbers, 45 minus 23. Again, we would do 5 minus 3, oh, that's 2, 4 minus 2, 22, perfect. Good check, but we need to be able to explain our thinking. So for them, they would draw the 4 10s, they would draw the 5 1s, and then they would take some away. They would start with the 1s, they take away 3 1s, they're left with 2 1s, and they would take away 2 10s, they're left with 2 10s. So they're left with 2 10s and 2 1s, and again, it's the same answer. It's really nice and easy when you don't have to change any of the numbers like the 10s or the 1s, but let me show you how you would do it with regrouping. So we just did addition and subtraction without regrouping. It's the easiest way to do it, but now we have to be able to do it with regrouping as well. So if I had the number 23 and I added it to 49 this time, as you can see, I'm going to have to, what we did is carry the 1, but we're going to learn how to explain it and how the kids are working on it with their place 10 or place value pieces. So the 3 and the 9 is 2, you bring 1 up here, oh, and then you've got 7, done, end of story. But we want to check it. So the kids know they're adding, so they do the 2, 3 dots, they are adding more, so they're drawing more. They do 4, and they do 9 dots. So again, they're going to do the 1s first. Now, they know that one of those dots can get moved, and it makes a 10. So what they can do, what we kind of teach them, is to cross this off and add it to the 10s here. So now they're left with 2 1s, and then they have 1, 2, 3, 4, 1, 2, 3, that's 7 10s, and they're able to get the same number. By moving it to the 10s, by showing that they know that the 10 1s makes a 10, they're able to move it over there and have it ready for when they do the 10s place. And additionally, if we do an even bigger number, especially when they're doing the triple digit, we want to make sure that they've got that down. So if we have 75 and 36, we're going to see it this way. Again, we know how to do this and we get the answer. Okay, but we're not able to explain it as well as if we see, okay, there's 7 ones, there or 7 tens, there's 5 ones. We're adding 3 tens and 6 ones. We're doing this first. We know that 4 of these ones can be added with this group to make a 10. We're left with 1 1 here. Then we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We get 11 tens, and that makes 111. So that's how you would do addition with regrouping, and that is 2 different problems to kind of show the change from the double digit to the triple digit. Now with subtraction with regrouping, it is a little bit more difficult. It's a little bit more drawing. It's a little bit more abstract thinking. So if we have 72 minus 25, we know in our heads we would, we're going to borrow a number from up here somewhere. It's 12, 5, 7, and then we're 2, and we're done. But I can tell you 100%, I don't know borrowing whatever. I'm not really sure how to explain that. So I look up here. The kids know to draw 7 tens and 2 ones. Now, they can't take 5 ones away from the group that we already have. So what they'll do is they'll create some more ones by changing one of the groups of tens into 10 ones because they understand that ones make a 10. So now I can cross off 5, and I'm left with this strand here. There's 7 of them. There's a group of 5 and a group of 2. And then I see I need to cross off 2 tens. So I'm crossing off my 2 tens here, and I'm left with 1, 2, 3, 4 tens. And that is an easier way for the kids to show their work, for me to see their thinking. Okay, they changed it, they regrouped it. Oh, they were able to cross off, and that was awesome. So this is, again, just a way for me to see, for me to know visually what they're doing and help them work through the process. It's also a way for them to be able to explain it to someone and show their conceptual thinking. The last one I'm going to do with subtraction is one with a triple digit, so you can see how we represent that. So if we have 121 take away 14, we're going to check it this way. And again, we would do this, we do this, we would have this, and we would say, 1 was a 0, and 1. So then what they would do, how they would show it with their base 10 blocks, is they would have 121, and they would have to take away 14. They would make one of those 10s into 10 ones. They would take away 4. They would be left with 7. Then what they would do, oh my gosh, I think this is wrong. Is they would take away 1 10. I'm right. Okay, I'm getting there. Sorry, this is what kids do. And they sit and they look and they try to figure it out. And it's hard for me because I didn't learn it this way. So I'm trying to make sure that they're doing it the right way. So you take away the 1 10, and then you're left with 0 tens, and you're left with 100. So then you get 107. So it is good for kids to kind of work through the problems. And when they get harder like this, they're able to kind of recheck their thinking. So even teachers make mistakes sometimes, but this is how you would do the subtraction with regrouping with a triple digit number.